Okay, so look at number 1. And this says fluorine-21 has a half-life of approximately 5 seconds. So that's a pretty short half-life. What fraction of the original nuclei would remain after 1 minute? All right, this one's going to be pretty long. Okay, so what I would probably do is go out here to the right side of your paper where you have a decent amount of space and draw your T-chart. Okay, so right here, this is going to be your time. Over here, this is going to be your amount. All right, it doesn't matter how much you have because it says what fraction. Okay, so at time 0, how much do you have left?
On the interruption, students needing their pictures taken, I through J, please go to the auxiliary gym.
No. At time 0, you have 1. What's 100% of a fraction? 1. So that means that you have 1. Okay, that's what you're starting with. All right. Now, the half-life is 5 seconds. So after 5 seconds, how much are you going to have left? You're going to have half. So 1/2. Okay? Because it's asking about fractions, so I wouldn't turn it into a decimal. All right. After 10 seconds, how much are you going to have left? 1/4. After 15 seconds, how much are you going to have left? 1/8. After 20 seconds, how much are you going to have left? 1/16. Sorry, guys. You're just cutting it in half every time. So 1/4 is a half of a half. 1/8 is a half of a fourth. 1/16 is a half of an eighth.
We're turning into a minute?
Yes.
My whole paper.
So 25 seconds is going to be 1/32. Okay?
Oh, 1/32. Yeah.
1/32.
Wait, how?
The next one's
Oh, wait, hold on, never mind. I went to.
Is everybody with me so far?
Yeah,
Okay.
just give me like 30.
Literally, you're just doubling the bottom number. Okay, that's all you're doing. So 30 seconds, I would have 1/64. 35 seconds, I would have 1/128. Okay? 40 seconds, I would have 1/256. 45 seconds.
45.
Yeah, we're going to 60.
Are you kidding me?
No, it's 1 minute. Oh, yes. So after 45 seconds, you would have 1/512. After 50 seconds, you would have 1/1024. And after 55 seconds, you would have 1/2048.
How do you know this?
Just doubling it. And last but not least, after 60 seconds, which is 1 minute, you would have 1/4096. So what that means is, whatever the amount of mass that you have, after 60 seconds, you would have 1/4096, that amount left over. Okay? So that is your fraction, 1/4096.
Oh, that's a good answer.
All that.
There's gotta
Just
be
to
an
get
easier
them.
way, right?
So do we
What?
just start?
I said there's gotta be an easier way.
There is an easier way, but I'm not going to show you yet.
Wow.
Withholding information. I know, you can just.
Because the shortcut, if people don't understand it, it can be confusing. You really need to know your exponent rules.
There's gotta be like a thing I should do.
There is a way to do it, but some people won't get it. So, all right. Now, the next one, here's the good thing about this. Once you've done a table like this, you can use that a lot for future questions. Because number 2 says iodine 131 has a half-life of 8 days. What fraction of the original sample would remain at the end of 32 days? All right. How many half-lives are you undergoing if the total time is 32 days and the half-life is 8 days?
4.
4. Well, look. If you start right here and count with me. So this is 0. This would be 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives. How much do we have? 1/16.
Is that really all you have to do?
Well, it's not always given to you in fraction form, so it's not all you would have to do, but sometimes you can use stuff you've previously done to help you in the future. All right. Now, number 3, there's actually 3 questions. All right, so for number 3, it says the half-life of chromium-51 is 28 days. That's important. If the sample contained 510 grams, how much chromium would remain after 56 days? How much would remain after 1 year? How much was present 168 days ago? Okay,
You're confusing me.
we're going to break it down one question at a time. So the first question we will answer is, if the sample contained 510 grams, how much chromium would remain after 56 days? So go ahead and write a T-chart. This one is not going to be as long. All right. Now, at time 0, how much are you starting with? 510 grams. All right. How long is the half-life? 28 days. So after 28 days, how much do you have left? 255 grams. That's half of 510. Everybody with me so far?
Yeah.
All right. Now, another 28 days would be a total of 56, which that's where we want to stop for the first question. So after 56 days, how much would I have left? All right, 127.5 grams. Okay, so the first question, the answer is 127.5 days, or 5 grams. Sorry, 127.5 grams. All right, everybody with me so far? Okay, now, it also asks how much would remain after 1 year. Okay,
A year?
a year.
That's 300.
It is 365 days. So I'm going to create this T-chart over here. Now, I'm not going to start from 0. We already went to 56 days. So I'm just going to take 56 days and start at that point. So at 56 days, I would have 127.5 grams.
Can't you just
Divide what by 5?
How did you get divided by that?
I didn't. Caleb said that.
Like the year.
We're not going to do that yet.
Attention students needing pictures with the last name K through L, please go to the auxiliary gym.
All right. So 56 plus another 28 days. That is going to give us 84 days. All right. And 127.5 divided by 2, that's 63.75 grams. Okay. Now 84 plus another 28 days. That's 112 days. And then 63.75 divided by 2, that's going to give us 31.875 grams. All right, after another 28 days, that's 140 total days. And then 31.875 grams divided by 2, that's going to give us 15.9375 grams. All right, another 28 days. That's 168 days. Okay? Divide 15.9375 by 2. That gives us 7.96875 grams. $168 plus another 28 days. That's 196 days. And the 7.96875 divided by 2. That's going to give us 3.984375 grams. I have a calculator. Now I'm just doing this in my head. It's very impressive. Yeah. Just rattling these numbers off, give or take. All right. 196 plus another 28. That is 224.
You're like doing it super fast.
Doesn't take long when you've got a calculator. Now, if I divide the mass by 2, that's 1.9921875 grams. I'm not really paying attention to sig figs here, by the way. 224 plus 28, that's going to give us 252. And half of that amount will give us 0.99609375 grams.
Why would they do this?
I'm sorry, I thought you was
All right. Now, 252 plus 28. That's 280. We all are.
Can this be
I'm not,
over?
because I started at the top.
All right, so 280. Then divide your mass by 2. That's going to give us 0.498046.875 grams.
Can we just like put the 2 decimals and not write all the decimals?
We will in the future, but not right now. All right, after 308 days, that's the next half-life. You would have half of that, which is 0.249023438 grams. Look,
I actually put
get the understanding and the final answer. Okay?
Could this be over now?
308 plus 28, 336.
Oh my god.
We are almost there, people.
Are you sure about
Okay? And 0.249023438 divided by 2. We got 0.124511719 grams. And, okay, last but not least, so this is only going to get you to 364 days, but we're going to say that that's 1 year. Okay? Divided by 2, that's going to give me 0.0622556 grams. All right.
That's your answer.
That's my answer to the second part.
That's just the second one?
That's just the second.
Oh, yes.
What's the answer, Peter?
Oh!
All right. So the answer is 0.06225586 grams.
We could have
All right.
just divided it. That would have been faster.
Now,
You didn't want to know it.
okay. Here's what you can do. I'm going to show you the shortcut. But here's the thing.
Can we use it now?
I'm not going to spend 100 years explaining this shortcut. If you don't understand the shortcut, you're going to do the long way. Okay? Is that a deal?
Yeah.
Because the shortcut is not necessary, but it is possible to do the shortcut.
Okay.
All right. So what you can do is, in this case, if you have 365 days in 1 year, and you know the half-life is 28 days, all right, that's like 13.03, blah, blah, blah. We're going to round that to 13 half-lives. Okay? Does that make sense?
Yeah.
So we go through a half-life 13 times. What you can do in this case, you can take 1/2, raise it to the power of 13. Okay? Everybody with me?
Yeah.
So when you plug that into your calculator, put it in parentheses. 1 divided by 2, close parentheses, and then raise it to the power of 13. All right? Everybody understand that? Hit enter. And then multiply that by your beginning amount, which is 510 grams. And that gives you the same number. Okay, right there. 0.0622, 0.0622.
Oh, that is way easier.
I
Okay.
can do that.
So if you understand it, you can do that.
Is there like a formula you can write down?
There's not really a formula. You're just taking however many half-lives you have and raising it to the power of, taking 1/2 and raising it to that power of however many half-lives you have. And then multiply that by the amount. Now, listen, if you're only trying to get a fraction, you don't have to include the mass. So like up here, now you're only going to get this if your calculator can give it to you in a fraction. But let's say that we were trying to get this one in a decimal form. Well, if I know that my total time is 1 minute, which is 60 seconds, and my half-life is 5 seconds, 60 divided by 5 is going to give me 12. Okay? Well, if I do the same thing, 1/2 to the power of 12, okay? 1,496, 1 over 4,096, that's the decimal equivalent to it. Okay, so some calculators you can actually change that around to where it'll actually give it to you in fraction form. This one, yeah.
Wait, Mr. Harrison, where did you get the 13?
There's 13 half-lives.
Oh, okay.
So all I did was take 365 divided by 28. Because 28 is the time of the half-life. 365 is the total amount of time. Okay. Now, there's actually a third question in this question. It says how much of the chromium-51 was present 168 days ago. All right, this is different than the rest of these because every other one we have tried to predict how much will you have left in the future. This one we're trying to figure out how much did I have in the past. So instead of cutting it in half, if we're going backwards, what are we doing? We are doubling it. You're doing the opposite if you're going backwards in the past. The opposite of cutting something in half is doubling it. Okay? Does that make sense to everybody? So if you're going forwards, you're cutting it in half. If you're going backwards, you're doubling it. All right? So 168 days ago. Now, I'm going to show you the shortcut on this one. Okay? I'm not going to do another T-chart that's 3 miles long again. So in this case, if we know it's 168 days, 168 divided by the half-life, which is 28, that gives me 6 half-lives. Everybody understand that? Now, 6 half-lives, that would mean I would double 510 6 times. So all I have to do in this case is take 2 to the power of 6. That's like doubling something 6 times. So 2 to the power of 6, that gives me 64. So 64 times 510, that gives me 32,640.
Alphabet M through N. Please go to the auxiliary gym.
Okay?
That gives you 500.
Look, what I did, I found out there were 6 half-lives. I took 2 to the power of 6 because I'm doubling it 6 times, right? So if I double it 6 times, that's like multiplying it by 64, okay? Which gives me 32,640 grams, okay? Look, I'll show you this one just real quick. I'm not going to be super slow about it, but if you create your T-chart, this is the way it would look. You start with 510 grams, or whoops. At time 0, you start with 510 grams. After 28 days, you would have 1,020. And this is 28 days in the past. Okay? After 56 days in the past, I would have 2,040. After 112, I would have, 56 plus 28 would be 84. Sorry. After 84 days, I would have 4,080. I'm just doubling it every time. After 112 days, I would have 8,160. After 140 days, I would have 16,320. And then after 168 days, which was where I wanted to start, I would have 32,640, which that's what I got. Okay? So there's 2 ways of doing it, using the T-chart and using the math. Okay? Everybody with me?
Can you show me number 3 again?
All right, look, we're going to do a couple more examples together. Marley, we'll talk individually. Okay, number 4. So here's the thing. Some things that are used in medical testing have such short half-lives that they have to transport it to a place where it can be used. But if it takes, 30 minutes, 60 minutes to get there, they can't start out with the amount that they need when they get there, because some of it's going to decay by the time they get there. So what they'll have to do is figure out, how much do I need to start with when I leave so that I end up with the amount that I need when I get there. Does that make sense? So, number 4 says if 20 grams of a radioactive isotope are present at 1 p.m. and 5 grams remain at 2 p.m., what is the half-life of the isotope? All right, so here's what you have to do. Start out with your time and your amount, okay? And figure out how many half-lives this undergoes. So at time 0, how much do we start with? We start out with 20 grams. Okay, and I don't know how many half-lives this has undergone. Okay, and we can actually call time 0 1 p.m. if you want. Okay, now, how much are you going to have left after the first half-life? 10 grams. How much are you going to have left after the second half-life? 5 grams. And we know that at 2 p.m., we end up with 5 grams. So what's in the middle of 1 and 2 p.m.? 1:30. So how long is your half-life? 30 minutes. Does that make sense? Sometimes you kind of have to just use what you know to be able to figure out what you don't. Yeah, this is 1:30. Look, we know that at 1 p.m. I start with 20 grams. At 2 p.m. I have 5 grams. Well, how many times do I have to go through a half-life to get from 20 to 5? I go from 20 to 10, that's 1 half-life, and I go from 10 to 5, that's 2 half-lives. So 2 half-lives in a span of an hour, that means each half-life was 30 minutes. So that means that the half-life is 30 minutes long. That's my answer. All right, number 5, you actually can answer from some of the stuff we already did. Because chromium-48 decays, and after 6 half-lives, what fraction of the original nuclei would remain? All right, go back to your big long one that we did for number 1. Just count down 6 half-lives. Okay, so this is 1, 2, 3, 4, 5, 6. So the fraction that would remain is 1/64. Okay, that's my answer for that one. All right. So this is what I would like for you to do on your own. Okay. I would like for you to do number 6. I would like for you to do number 7. And number 9 is kind of your challenge question. So 6, 7, and 9, I'd like for you to do. That's 3 questions.